Hello guys and welcome to my YouTube channel. So we're talking about logarithm in indices and logarithm. So here is for you to know that a logarithm of a number to a certain base is the power of which the base must be raised to obtain that number. So if you have something like log n base b equals to x, then n also equals to b raised power x. So also notice that logarithm using calculations are normally in base 10. They are called common logarithm. That's if you have something like log 1000 equals to 3, it's taken to mean that log base 10 equals else base 10 1000 equals to 3. That means the base is 10. If there is no base given, you should know that the base there is 10. So we are comparing the powers and logarithm. So if you have something like 1000 equals to 10 raised power 3, that's the same thing as log base 10 1000 equals to 3. So it's also when you have something like 100 equals to 10 raised power 2, that's log 100 equals to 2. And remember our common logarithm that if there is no base, you should know that it's base 10. And we have 10 equals to 10 raised power 1, and that's log 10 equals to 1 in logarithm. Then in powers, when we have 1 equals to 10 raised power 0, our laws of indices in our previous lesson, that they said once the number is raised to the power of 0, it equals to 1. So that's it here. Then the log 1 equals to 0. So since log 1 equals to 0 and log 10 equals to 1, the logarithm of any number must be with any number between 0 and 1 must be between the logarithm of any number between 1 and 10 must be between 0 and 1. So logarithms of numbers are found with the help of four-figure table. So we want to know how to get the logarithm of a given number. So logarithm of a number has two parts. We have the integer part and the decimal part. So talking about the integer and decimal parts, let's show how the integer and decimal fraction is. So I'll be using a pointer. So here now, let's use, I guess, a letter will be pressed. Okay, laser pointer. Later. So here now, this is an integer, the whole number, the one before the decimal point, that's the integer. Then the one after the decimal point is the decimal fraction. So now, how to get this integer is what we are going to look at now. So now to get this integer, the integer of a number is 1 less than the number of digits to the left of the decimal point in that given number. So if they give you a number like 7,000, so here there are 5 digits before the decimal point. Remember, if you have a number like this, the decimal point is at the end, so there are 5 digits before the decimal point, and here there is 5 whole numbers, that's 5 full digits. So the integer part of this will now be 1 less than the number of digits to the left of the decimal point. Remember that. So it will be log 3007 is log 37,000, sorry, is 4. The integer part of log 37,000 is 4. So therefore, log 37,000 is 4.5682. This 5682 we got it through the logarithm table. So we have to check 37 under 0 difference 0, something like that. So we get to know how to get that part. Here we're talking about the integer part, that's the one before the decimal point. How to get that? Remember, is 1 less than the number of digits to the left of the decimal point in that given number. So next we'll be talking about how to get the fractional part, that's the decimal fraction. So here we have two methods. So let's go to method 1. Using this example, find the log of 33.5. So we need a four-figure table for this. So here they said, for an example, find the log of 33.5. So to get the fractional part, we have to go along the rule beginning with 33. So now let's go to the place that we have 33. So let me change my this. So use a pen. So okay, I'm coming. And to zoom it. Yeah, let's zoom this side of 33. So they say we should go along the row of 33. This is 33, and they said and stop at the column with 5 at the top. So this is the row of 33, this row. So they say we should stop at the column of 5. So the column of 5 sits here, so we have to trace it down to where 33 is. Where 33 is. So this is the column of 5, and this is where 33 is. So that's 5 to 50. That's the digit here. 33 under the column of 5. This is it, 5 to 50. So under the so this gives the figure 5 to 50, and that's how we get our decimal part. So here now, to get the integer part, remember we have to do 1 less than the number of digits towards the left side of the decimal point. And so these are the numbers 3 and 3. So how many numbers are here? We have 1, we have 2, so that's 2 numbers. So now 2 digits, that's 2 digits at the left side of the decimal point. So now we have to do 1 less than it, so that will be 2 minus 1, 2 minus 1, which equals to what? 1. So this is our integer. So now we'll now use that integer 1, then the decimal point, then our fractional part. Remember how we got the fractional part? 33 under 5, and that's 5 to 50. Let's not forget it. Let me zoom it again so I will see it. Yes, I'm coming. 33 under 5 seats. 33 under the column of what? Under the column of 5 seats. 33 under 5, that's 5 to 50. And our integer part is what? 1.5 to 50. So that's how we got our answer. So now log of 33.5 is 1.5250. Remember how we got our integer and how we got our fractional part. So the second method for this is changing it using standard form. Here we are using standard form that we learned in the previous lesson, and we are also going to be using reading of the logarithm table. So me, I do prefer method 1 because it's shorter and faster than method 2. So here they say we should change 33.5 to its standard form. Remember, it has to be 1 decimal point. So, sorry, 1 whole number, then several any amount of decimal points. So, 1 whole number, that would be 33.5 equals to, let's use a pointer to, okay. So here with 33.5, changing it to standard form will be 3.35 times 10 raised power 1. You know we only move the decimal points once. So that's why it's 10 raised power 1. So expressing 3.35 now as the power of 10. So we have to express this our standard form number to a power of 10. Since this one already has a power of 10, so we have to express 3.35 as a power of 10. So to get that power of 10, we have to now use our logarithm table. So we have to get the log of 3.35. So going back to what we learned in the last slide, how to get our integer parts. So our integer part will be the number of 1 less than the number of digits at the left side of the decimal point. So the left side of the decimal point is here. So how many digits are here? That's 1. How many digits is here? Sorry, that's 1 digit. So 1 less than this digit is what? 0. So that's how we got our integer part as, or our integer as 0. Then to get our decimal fraction, our fractional part, is same reading of logarithm table. That will be 33 under 5. So reading it to, so let's zoom it, 33 under 5 as we did previously. That's 33 under 5. So remember, your integer only deal with the number at the left side of the amount of digits at the left side of your decimal fraction, while your fractional part, that's the decimal fraction, deals with all the digits there. That's all digits in that particular question. So going there, we have it as log this equals to 0.5250. Remember using method 1. So now that will be our power. That log of 3.35 will serve as our power. So it's going to be 10 raised by 0.5250. So it will be 3.35 times 10 raised power 1 equals to 10 raised by 0.5250 times 10 raised by 1. Remember our laws of indices. The first one, when you are multiplying two index numbers, you have to add the powers. So here we're adding the power 0.5250 plus 1. That's equal to 10 raised by 1.5250. So here we've gotten our answer as, so the power now is our answer. So the power is 1.5250. That's hence the log of 33.5 equals to 1.5250. Remember I said we should use, I like using method 1 because this method should have method 1, we have to use method 1, and we also have to use standard form. So I prefer the method 1. So the next slide will say okay, an exercise. So here I'm finding the log of 3.746. So if I show this solving, let's just try and grab some things. From here we have our integer. From here we can see our integer will be 0 because there's only just one digit at the left side of the decimal point. So 1 minus 1 equals to what? 0. Then here we have to read 37 under 4 difference 6 on our logarithm table. So reading it, remember what I said, the integer is this. Then reading our 4-figure table, let's zoom in. 37 under 4 difference 6. So zooming it, 37 under 4 difference 6. Yeah, so now this is 37. Yeah, this is 37 under 4, that's under the column of 4. So let's trace 4 down. That's 5729 difference 6. So 5729, then difference what? 6 will be here, this column. So difference 6 will be what? So 37, this is 7, so it will be 7. So now here it said difference 6. So we'll add the difference to what we got here. So that means we're adding 7 to 5729. Remember our 37 under 4. So 5729 plus 7 will give us what? Will give us 5736. So remember that's, to just shorten it, we have to do 37 under 4 add difference 6, and that's 0.5736. remember this is our integer and this is our decimal fraction, this 5736. So next, okay, so that this is also another question. Find the log of 4137. So before we show the solution, let's try solving it. So from here, the decimal point is at the ending of this number because it's a whole number. As you can see, there's no decimal whatever. So here is, there are 4 digits before the decimal point. So that means the integer will be 4 minus what? 1. 4 digits. How do you get it? Let's count it. 1, 2, 3, 4. That's 4 digits. So 4 minus 1 is what? 3. So that's how our integer is. Our integer is 3. Okay, here we're even using the second method here. So let's first use our first method to get it before we go into the second method. So it will be 3.41 under 3 difference 7, 41 under 3 difference add difference 7. That's this 41 under 3 add difference 7. That's 7 plus 6 160. That's 6167. That's our answer. So our answer will be 3.6167. See it here. I've gotten our answer here myself. So here Using the second method now, we have to change 4137 to its standard form. Remembering from using our, remember we talked about this in our last lesson. So changing it to standard form is 4.137 times 10 raised power 3. So expressing this 4.137 as the power of 10 will now be, we know to get the power we have to change 4.137 to log. So find the log of 4.137. Here the integer will be, how many digits is here? 1. How many digits for this decimal point here is 1. So 1 minus 1 is 0. So that means our integer here is 0. Then the next thing is our, to get our decimal fraction. So to get our decimal fraction will still be 41 under 3 different 7. So now we have read that, and that gave us 6167. Yeah, 16160 plus 7. So that's that. So it will be log 4137 equals to 10 raised power 0.6167 times 10 raised power 3, bringing it back, equals to 10 raised power 0.6167 plus 3. Remember our first law of indices, that's 10 raised power 3.6167. So, and now you guys should know that anytime we are using our 4-figure table, the anytime we are using our 4-figure table, make sure that you read the table. Make sure that you read the table properly. That's, always make sure that the number taken from the differences column is in the same row to the rest of the figures. That's what we try to check now. Like now, you can be reading 40 now and you want to check the difference table. You might think, when you go to the difference table, you might not read the difference of 39 instead of 40. So that's how you have to be very careful when reading your logarithm table. So therefore the log of 4137 equals to 3.6167, sorry. So now we are going to antilogarithm. So antilogarithm is the opposite of logarithm. It can be gotten either with the use of log table or antilog table. So we can be gotten either the use of what, log table or antilog table. So we'll be using two methods here too, as we did earlier on, that I'll use the standard form and just go straight to the 4-figure table. Here we are going to be using the log table and also the antilog table, whichever one you would like. That's what you should use. So to get the antilog of a number, look up the fractional part, then use the integer to place the decimal point. This is very important for you to note. Note that anytime you want to get the antilog of a number, make sure you look up the fractional part only. Then the integer part is only used to place the decimal point of that number. So for our first example, we find the antilog of 0.5775. So here now, here using log table, we have it as the fractional point. Remember, fractional parts, we are only looking up the fractional parts. Then the integer part is used to get what, the amount of the to place the decimal point, sorry. So now the fractional part is 5775. So this appears across from 35 and under 8. This is using our log table. Sorry, my diagram of my log table is not here, so I'm so sorry for that. So here it will be, it's appearing 37 and under 8, under the column of 8. So our answer here will now be 0.378. If you look through your 4-figure table, you understand what I'm saying. So since our integer here is 0, so we are going to add 1 to our integer. So it will become 0 plus 1 equals to 1. So now you now move the decimal point once. Remember, our decimal point here is at the front. So now since we're adding 0.1 equals to 1, so we're going to move the decimal point only once to this place. It's our decimal point only once. So that means the antilog of 0.5775 equals to 3.78. Next one is using antilog table. So for me, I prefer using the antilog table because it's so direct. Now we are going to find the figures 57 under 7 difference 5. 57 under 7 adding the difference of 5. How we read the log table is how we're going to read the antilog table. As I say, it's so direct. While the log table, you have to look in between, like you will start checking the columns. Don't worry. Anytime when next I'll check, we should go to our next slide. We see whether our log table and antilog table is there. So you understand what I'm saying. The figures on along 57 under 7 is 3776, and adding the difference 5, and the difference 5 here is 4. So if you should add the difference 5, is 3776 plus 4, that's 3780. That's 0.3780. Add 1 to the integer. Our integer here is what? 0. So we are adding 1 to integer 0. That is 1. So if we should move the points, it will be 1. That's moving the points here once. That's 3.78. That's our answer. So that's the antilog of 0.577. The antilog of 0.577 equals to 3.78. Our next question here is find 10 raised to power 2.7547. When you have something like this, 10 raised to power something, just know that they need to find the antilog of that power. So to solve this stuff, we have to find the fractional parts. Here I kept the diagram of the logarithm and the antilog. So we are using the antilog table here. If we should check the fractional parts up in the antilog table, so let's zoom in. We are looking for what? 75 under 4 difference 7 using the antilog table. So 75. Oh shit. My logarithm table is not complete. I'm so sorry about this. So it's just the same way as we checked our log. We have to go through 75 under 4 difference 7. We'll add the difference of 7, whatever the 7 column gives us, add this difference, we'll add it to our 75 under 4. We'll add them together. I'm so sorry for this. The integer part is 2. So remember what you are going to do. You just add 1 and move the decimal point. So if you add 1, it will be 3. So we'll move the decimal point 3 times. That's 1, 2, and 3. So the decimal point will be here after 8. So the answer will be 568.4. The next question is the antilog of 4.3. Here, the fractional part here is 3. And since we are going to use 4-figure table, we have to change it to 4 figures. So it will be 0.3000. So 0.300 using the log table. Let's zoom in. So using the log table, we have to find where 3000 fall under. So let's look from here now. Let's start from here. No, this is not 3. This is not 3. This is 3. Oh, this is 310. We have passed. So let's go back. This is 2989. So this is closer to 3000. This this is closer to 3000, so that will be 19 under 9. So now we have to find difference that will add to this to make it 3000. So 11, if we add 2989 to 11, it will give us 3000. So that means our answer will be 19 under 9 difference 5. So therefore our answer is 1995. That's 1995. Sorry for my mistake. So here the integer part is 4, which shows that there are 5 digits before the decimal point. Remember, when we want to get the antilog of a number, we have to add 1 to the integer part. So here we move the decimal point 5 times, but we have only 4 digits here, so we have to add 0 to make it 1, 2, 3, 4, 5, to make it 5 digits before the decimal point. Okay, so this is calculations using logarithm. So here we'll use log and antilog to calculate questions. So to get this part, we have to note this, that when you are multiplying number using logarithm, you have to add the log of that numbers. If you are dividing number and you want to use logarithm, you have to subtract the log of that number. When you have a number raised to a power, you have to multiply the log of that number by the power. Then if you have the root of a number, you have to use the log of that number divided by the root. So here this is similar, it's really similar to the laws of indices. To find the so this is very similar to laws of indices. Note that the basic principles of calculation using logarithm depend on the laws of indices. As I say, it's very similar to logarithms. Remember, in our first law of indices, we have that if you are multiplying numbers, you have to add their power. If you are dividing, you have to subtract their power. So here we are adding the log of the number, we are subtracting the logarithm. That I say is very similar to the laws of indices. So our first question here is 34.83 times 5.427. Here we'll draw our table given our number and log this. So under the first number we have it as 34.83. Then we have 1.5420. So and the second number is 5.427, and the log of this is 0.7346. My log table is not here, but if you have yours, please open yours and check it, because from here we can get our integer. So our integer here will be, how many digits is here? 1, 2. So that will be 2 minus 1, that's 1. And how many digits is here before the decimal point is 1? So 1 minus 1 is what? 0. So here our integer is 1 and our integer here is what? 0. So the decimal fraction of here will be 34 under 8 difference 3, and the decimal fraction of here will be 54 under 2 difference 7. So since we are multiplying these numbers, we have to add their log. So it will be, if we are adding this log, 0 plus 6 is what? 6. 2 plus 4 is 6. 4 plus 3 is 7. 5 plus 7 is 2. 12, sorry. So we have to write 2 and carry 1. So 1 plus 1 is what? 2. That's 2.276. So using our anti-log table to get back our number will be 27. Remember, we're going to use only the decimal fraction to find our number, then use the integer part to place our decimal point. So here will be 287 under 6 difference 6. That will give us 1891. So since our integer is 2, we'll add 1, that's 3. That means there will be 3 digits before the decimal points. Next question here will be, evaluate 4562 divided by 98.676. So the same thing, you draw your table and you draw a table and you put in your numbers out, 4562 and 98.76. From here our log of 4562 will be, that will be How many digits are here? 1, 2, 3, 4. 4 minus 1 is what? 3. So our integer is 3 here. Then here is 1, 2, that's 2. Minus 1, that is 1. So our integer is what? 1. So to get fractional part to be 45 under 6 difference 2, that's 6592. Then the fractional part of this one is 98 under 7 difference 6. So remember, division of numbers equals to subtraction of the log of numbers. So we have to subtract the log. So from here, we'll borrow 1 from here. That will make here 8, then 1 here. That will be 12 minus 6. Then 8 minus 4 equals to 4. Then here, this number is too small for this. So we'll borrow from here. That will be 5. Then here, 15 minus 9, that's 4. Then borrow 1 from here, that will be 2. Here, we'll make it 15. 15 minus 9 is what? 6. Then 2 minus 1 is what? 1.646. So we have to find the antilog again to get the number. So that will be 64 under 4 difference 6, which should give us 4619. So here we have our integer as 1. Adding 1 to it will be 2. That means there will be 2 digits before the decimal point. Therefore, 4562 divided by 98.76 equals to 46.19. That's that. Then our next question here is 61.03 raised power 2. That's the law of power. So here we are going to find the log of 61.03. That's 1.7855. Remember, our integer here will be 2. How many digits are here? 2. 2 minus 1 is what? 1. Then our decimal fraction will be 61 under 0 difference 3. So if we have to check this, let's zoom in. So our logarithm, which one has 61, it should be this. So 61 under under 0 difference what? 3. So 61 under 0. Remember they said we should make sure our differences is across is on the same row with our our digits. So 61 under 0 difference 3, and 3 was 2. So difference 3 is 2. That will be 5853 plus 2. That's 5855. So 5855 times 2. God, there's a mistake here. I'm so sorry. Here is meant to be multiplication sign. So it will be 1.5855 times 2 here. And that will give us 3.571. So 3.571, changing it back to antilog table. Yeah, let's use the logarithm table to get our antilog here. So using the logarithm table, we'll be finding 571. So 571 should be around here. Here we have 5. So this 579, no. This 5740, no. 571, that's close. Look, 5705. So it will be 5. That will be 37 under 2. Then it will be 37 under 2. Then difference 4. Yeah, there's 7 under 2 difference 4. That's 3724. So remember, we have to add 1 to the integer to know how many digits before the decimal point. So it will be 4. So how many digits are here? 4 digits. So that's that. Then the next one is evaluate 10 root 2.882. So remember, when you are dividing, when you are finding the root of a number, you have to divide it by 10. I'm so sorry for this mistake. Here is meant to be division sign. So finding the log of 2.882 will be 0.4606. So divided by 10 will give us 0.04606. And the answer to that will be, our antilog of that will be 1.112. So that will be root 10 root 2.882 will be 1.112. So the next question here is 17.2 raised power 2 times 4.93 divided by cube root of 675 675 and 40. That's 6,750,000 cube root of it. So yeah, we are using the log reading. That's evaluating the axis and evaluates with the use of table. So we are using log reading. So using our tables, we'll find the log of 17.2, and this is it, 1.2355. Remember, when you have power, you times it. So 1.2355 times 2 will give us this. And when you have multiplication, you add 4. So the log of 4.93 is this. Adding both of them together will give us this. Then log of 6,750,000 is this, 6.8293. And the cube root of it will be the log divided by 3, and that is 2.2764. Remember, when you have the division sign, you have to take minus, that subtract. So we have simplified our numerator, and this is the final answer of our numerator. So we are subtracting the denominator from the final answer of our numerator. So it will be 3.1638 minus 2.2764, and that will give us 0.8874, and the antilog of that will be 7.716. And that's all the exercise I have for now. Thank you for watching, and please subscribe and hit the notification button to get notified when I drop my next video. Thank you so much.